Welcome to the first video of section 3.4. 3.4 covers a topic called linear programming. If you think of the last problem we did in the 3.3 video, the one that talked about the assessment and you had questions of type A and type B, but you only had a certain amount of time and you could only answer 16 questions. That's linear programming. So it's a real life problem where you have constraints of some kind, something that is holding you back or limiting you, and you want to find a maximum or minimum of some kind. So the first video of 3.4 is going to be the basics of linear programming. So it's not going to be word problems, it's just going to be the basic skills. And then when we watch the second 3.4 video, it's going to be the word problems. This section puts together everything that we've done so far in this chapter. So we're going to have to graph systems of inequalities, we're going to have to find solutions, so find where lines intersect, and then we're going to have to use those solutions. So let's take a look at problem 1. You are given the graph of the constraint inequalities. Use a table to find the maximum and minimum values of the objective function. Okay, so a few things we got to look at here. First of all, this equation, this is called the objective function. Looking at the question, we want to find the maximum and minimum that that objective function takes on within the shaded region. Within the shaded region. Now, one thing that's important to know is that the max or min always happens at a vertex of the shaded region. So looking at our shaded region, the max or min is not going to happen anywhere in between. It's just not going to. It's only going to happen at one of these points, one of the 4 vertex points. So the max or min only happens at one of the vertex points. Now, we don't know just by looking at the points which one will give us a max and which one will give us a min, so we're going to need to test them out in a table. So what you're going to do on your table, one side you're going to put all the points. The other side, you're going to be plugging those points into the objective function. So if I list all my points out, I have 0, 0, 0, 6, 2, 7, and 5, 0. So plugging them in, 0 minus 0 will give me 0, 0 minus 6 will give me negative 6, 2 minus 7 will be negative 5, and 5 minus 0 will be 5. So again, we need to think about what we are asked to find. We're asked to find the max and the min. So largest number that we see is 5, that'll be the max. Smallest number is negative 6, that'll be the minimum. Then here's how we want to write our answer. We will say that the maximum is 5 at the point 5, 0. We say that the minimum is negative 6 at the point 0, 6. So this is our answer. So general process, you're going to plug in those vertex points, the vertex points of the shaded region. It's called the feasible region. And find whatever you're asked for. In this case, we were asked for the maximum and the minimum. Sometimes you'll just be asked for one or the other. Now, if we look at example 2, in example 2, we don't have the shaded region. We have to sketch that shaded region. So example 2 says, sketch the graph of the constraint inequalities, label the vertices, then use a table to find the max and min. So again, we're going to take a look at the information that we are given. This top equation is again called the objective function. You can always tell which one is the objective function because it has an equal sign, whereas all the constraints are going to be inequalities. So this one is going to involve the extra step or two of graphing these inequalities. Now you are going to need a straight edge, so if you don't have a straight edge, I would suggest that you stop the video, go find your straight edge and come back. Okay, so the first one, that x is greater than or equal to 0, that's just going to be our axis. So that would be right here. Now, if we want to figure out shading, this is greater than, so we would be shading this way. Now, what I'm going to do is I'm just going to put arrows to show where my shading is. That way, if I shade all three of these, I'm going to end up with a lot of shading. So I'm going to use the arrows just to indicate which way I would shade. If you actually want to shade with the blue, you can. Okay, next one. That y is greater than or equal to 0. Again, make sure that you use a straight edge. That'll be here. Greater than is up. Again, I'm just going to use arrows to indicate which way I would shade. And then the last one is that 2x plus y is less than or equal to 6. Okay, so this one is going to be a little bit more work. I'm going to have to make my xy chart. If I plug in a 0 for x, I get y to be 6. If I plug in a 0 for y, I get x to be 3. So I have my 3, 0 here, and then 0, 6 is right here. I still need to shade. If I plug in 0, I get 0 plus 0 is less than or equal to 6, which is true. So I shade towards 0, 0. Okay, so now I have to figure out where do all of those shadings intersect. Where do all the shadings intersect? And I can see that they all intersect in this triangle. That's where they all overlap. So that triangle, like above, is called the feasible region. And we know that the max or the min is going to happen at one of the vertices of that triangle. So if we identify all the vertices, I have the origin at 0, 0. I have that green point at 3, 0. And I have the other green point up above at 0, 6. So our max and min are going to happen at one of those points. Again, like above, way to figure it out is by a table. One side of the table, I'm going to put my points. The other side, I'm going to plug them into the objective function. So we have the point 0, 0, we have 3, 0, and we have 0, 6. First point, I get 3 times 0 minus 0, which is just 0. Then I get 3 times 3 minus 0, which is 9. And then I get 3 times 0 minus 6, which is negative 6. So our max is 9, our min is negative 6. So we will say our maximum is 9 at the point 3, 0. So again, the maximum or minimum is always with the objective function. Our minimum is negative 6 at the point 0, 6. Okay, so I know that that one was a lot of steps. General idea, you're graphing your constraints, you're graphing your inequalities, and then you're plugging them into the objective function. You're finding the maximum or minimum value in that objective function. What we're going to do with this in the next video is we'll be given a word problem, similar to that word problem with the test questions. And we'll have to write some constraints, so we'll write the inequalities, we'll graph them, again like we did in the test question problem, and then we'll find the maximum or minimum. If you flip to the next page, there's one more example. Okay, here's the example that you are going to try. This is similar to the example we just did. You are going to graph the constraints, label the vertices, and then find the maximum and minimum. If you are confident that you can do this problem on your own, then you are welcome to stop the video and give it a try. If you would like a little bit of help starting out, I will help you start out. I'm going to help us by graphing some of these constraints with us. So if I go to graph that top constraint, what's really nice, it's in slope-intercept form. So I'm going to zoom in a little bit to make sure that I can graph well. Okay. So we have 2x minus 4, so my intercept is negative 4. And then I'm going to go up 2 over 1, up 2 over 1, and keep going. Please use a straight edge. If you freehand this, you're going to have a lot of trouble finding the correct region. If I plug in 0, I get 2 times 0 minus 4 is less than or equal to 0. Negative 4 is less than or equal to 0, which is true. So again, I'm actually going to shade. I'm just going to put these arrows to indicate which way I would shade. Then if we do the green one, the intercept is still negative 4. This time though, my slope is negative 2. So I end up with this nice V shape. Plugging in 0, I get negative 2 times 0 minus 4 is less than or equal to 0. So negative 4 is less than or equal to 0, which is true. Again, think of a number line. Negative 4 is smaller than 0. So I'm going to shade towards 0, 0. Okay, at this point, I'm going to leave you to finish the problem. Here's what you're going to need to do. You will need to graph this last constraint, find the feasible region and label the vertices, and then find the maximum and minimum of the objective function that you are given. When you turn these notes in, I will be looking to make sure you have this problem finished. If you have any questions, please make sure you write them down or send me an email. Good luck.